Welcome to CCP Tools. This video explains the procedure for calculating 4-pin or 4-probe soil resistivity using CCP tools. Soil resistivity is a crucial aspect of site surveys for designing, maintaining, and troubleshooting cathodic protection systems. A more accurate site survey, including soil resistivity measurements, can result in a more effective and durable cathodic corrosion protection system. To initiate the process, first launch the CCP Tools mobile application. Proceed to the Site Survey section, followed by selecting Soil Resistivity Measurement. Within CCP Tools, you have the capability to calculate soil resistivity using both the Wenner and Schlumberger methods. The fundamental principle of the 4-pin electrode system, also known as the 4-probe method, is consistent for both Wenner and Schlumberger configurations. A low-frequency current is applied through 2 external electrodes, while the voltage is measured between 2 internal electrodes. The main difference between these methods is pin positioning. In the Wenner method, A equals C, so all 4 pins are equally spaced. In contrast, the Schlumberger method has varying distances with A is not equal to C. The Wenner method is more commonly used, and we will demonstrate it here. When you select the measurement type, such as Wenner, the required inputs appear. The first consideration is electrode spacing, which can be specified in various units. It is important to note that electrode spacing correlates with the soil depth involved in the measurement. For instance, if the electrodes are spaced 3 meters apart, the top 3 meters of soil contribute to the measurement and the reported value. If the spacing is increased to 5 meters, the first 5 meters of soil will be included in the measurement. The second parameter is electrode depth. The depth of the electrode can influence both measurement and calculation. It is advised that the electrode depth should be kept less than 5% of the electrode spacing to minimize potential measurement errors. Additionally, it is possible to enter both electrode space and depth in different units. The last 2 parameters are the applied and measured current and voltage. By clicking the calculation button, you can obtain the resistance value and soil resistivity. If you prefer your results in other units, you can easily convert them while using CCP Tools. In CCP Tools version 2, you can save the soil resistivity calculation in your project list along with a note and preferred name. This allows you to easily reference and use the calculation in future tasks. And that brings us to the end of this video. Thanks for watching.